Okay, guys, as quickly as possible or efficiently as possible, I want to go through some corrections on the most recent quiz that I gave you last week. And here we go. So let's say we're given a circle, and notice we have these segments crisscrossing inside, and we're trying to figure out what this length x is from here to here. Well, when you're inside a circle, guys, basically all you need to do is cross multiply. So what I'm going to do is take x with the 18, so that's 18 times x, and that's got to equal this 12. When I cross multiply, it'll be with the 26. So from there, I know that 18x will equal whatever 12 times 26 is. Let me do that real quick on the calculator. 312. So now I can now solve for x. All I need to do is divide by 18. So x must be 17.33 in this case. So I know the length from there to there is about 17.33. So inside the circle, we cross multiply. Now, notice how it's sticking outside the circle here. Well, this one we have a rule called outside times whole. Whole meaning the whole segment. So, notice here the outside part is 9. We have to quickly figure out what the whole segment is, which is 25, right? 9 plus this 16 would be 25. Let's set up the other secant, as we call it. The outside is 6. Notice that the whole secant is going to be x plus 6. So now we can follow our simple rule outside times whole, and it goes like so. I know the outside part here is 9. I'm going to times it with the whole secant. The whole secant is 25. That's got to equal the outside part. This part right here is outside the circle is 6. I times it by the whole segment called a secant, which is x plus 6. And now I can solve this. I can do 9 times 25. 225. That's got to equal, got to distribute here, right? 6x plus 36. And now I'm going to solve my equation. I'm going to minus 36. Minus 36. So I know that 189 will equal 6x. That means all I need to do now is divide by 6. So x, this segment from here to there, is 31.5 in length. Outside times whole. Okay, now number 9 here, you'll notice it's still sticking outside, but this is a special segment called a tangent. In other words, it perfectly touches the circle at that one point, and this length is completely outside. It never goes inside the circle at all, does it? So what we learn to do is square that tangent value. But anyways, it should be pretty logical. So here we go. So notice the outside part here is 8. We times it by the whole thing, which is x plus 8. That's got to equal 12. And do you understand that 12 is outside the circle, but it's also the whole segment? So I end up doing 12 times 12. So here I got some distributive property, 8x plus 64. 12 times 12 is 144. Now I'm ready to solve. I'm going to minus 64 both sides. 8x, in my case, will equal 80. That means when I divide by 8, x must be simply 10. So I know from there to there, inside that circle, we call that a chord, by the way. The segment inside a circle is called a chord. We know it has length of 10. And the outside part of it here, of course, has length 8. All right, now let's move to actual angles within or outside the circle. Notice here, we are told that from here to here is 116 degrees. Well, we should be able to figure out the rest of the circle, right? Shown in blue here, I'm going to take 360 and minus the 116. So 360 minus the 116 is 244. So now that we know that's 244, we have a rule that when I have an angle, see this angle right here is outside the circle. The rule says we take the bigger arc minus the smaller arc and divide by 2. Again, we take the bigger arc minus the smaller arc and divide by 2. So 244 minus 116 is 128. Divided by 2 is 64 degrees. So we just figured out that this angle outside the circle is 64 degrees. Notice this angle here is also outside the circle. And we already know that this from here to here is 82. And we know from this here to here is 190. And so therefore, what does our rule say? We take the bigger arc, 190, minus the smaller arc, 82, and divide by 2. So I'm going to take 190 minus the 82. That's 108 divided by 2 is 54 degrees. So this angle outside is 54 degrees. Okay, let's look at problem number 4. Now this one's more of a puzzle. Notice the question mark over here. So our goal is to somehow figure out what I'm coloring in blue here. What is that arc of the circle in blue, right? That's the question. Well, we do know this part of the circle is 152. That was given. And we were given this 74 degree angle inside here. Now let's look at this yellow angle. I'm coloring it yellow. Is it not cutting out, let me change colors here, this purple arc right here? Does everyone agree that the yellow inscribed angle, as we call it, that's 74 degrees, is cutting out the purple arc? Well, we should know that this arc is always twice its angle. So I'm going to take 74 times 2, and that's 148. So now what? Well, if you think about it, we all know a circle is 360 degrees. Let's take away the green part, 152. Let's take away the purple part. We found to be 148. And if I take away the green and purple, am I not left with the blue here? Yes, I am. So 360 minus the 152 minus the 148 is 60 degrees. So this missing blue arc is 60 degrees of the circle. Okay, notice how this angle here, even though it's made by this special tangent line, is still on the circle. I hope you agree that the angle's actually, the point of the angle, the vertex of the angle is actually on the circle. Well, if you agree with that, the same rule applies with any angle that's on the circle. So, what are we given here? We're given this 216. That goes from here to here. Can't I figure out what the remainder of the circle in green is? Of course. I'm going to take 360. I'm going to minus the 216. 360 minus the 216 is 144. So now that I know that's 144, would you agree my missing angle, which I'm coloring blue here, cuts out the green? And we just learned in the previous problem that the arc is always double its angle. So therefore, its angle is always half the arc. So I know 144 divided by 2 is 72. That angle right there in blue must be 72 degrees. Okay, notice this time we have an angle right here. I just marked in black. You should know it has a twin over here. These are vertical angles. Okay, notice the left angle right here cuts out the 108, and the right twin angle cuts out the 57 degrees. Well, what is the rule for an angle inside the circle? Is we average those arcs. In other words, I'm going to take the bigger arc, I'm going to add it with the smaller arc, and divide by 2. So I just want to point out, when the angle was outside, we would minus and divide by 2. Here we are inside, we add and divide by 2. So I'm just going to take 108, add the 57, 165, and now all I need to do is divide by 2. Oops, sorry about that, guys. So I know that this angle here has to be 82.5 degrees. Just like this angle here, its twin is also 82.5 degrees. All right, one more. Number 7. Notice we are missing this arc, which I'm coloring in black. It's the bigger arc, right? I'm going to call it X. We're missing X. But I do know the smaller arc inside the angle is 64 degrees. And we do know the angle outside is 58 degrees. So what is the rule? The rule says we take the bigger arc, which is the X, we minus the smaller arc, 64, and when we divide that by 2, we get the outside angle. Well, we just happen to know the outside angle is 58 degrees. So I now have an equation I can solve here. So I'm going to start by timesing by 2. So X minus 64 equals 116. 58 times 2 is 116. Let me just double check that. It is. Now all I need to do is add 64 to both sides, and I'll have X. So X in my case must be 180 degrees. Notice, if you look at the picture, guys, isn't that basically half the circle? That's why it's 180 degrees. All right, so guys, I had to go pretty fast because I just did a lot of problems for you. But again, you can pause, rewind this video over and over again as I go through each problem and try to dissect and absorb this information. But I do hope, nonetheless, that it helps you. All of this circle stuff, guys, will be on the final. So we got to make sure we do flashcards, take notes, whatever, and make it happen. All right? See you in class.